Hello everyone, welcome to my channel. Data lakes are not just for fishing, they are here to store our big data. But to prevent the data lakes from turning into swamps over time, we need organizers like Iceberg and Data Lake. Today we will quickly look at what Apache Iceberg is, why it is so popular, how metadata and manifest files work, and the most important differences between Apache Iceberg and Data Lake. If you are ready, let's first dive into the heart of Apache Iceberg and let's get started. Apache Iceberg is a table format project that is developed by Netflix to solve the chaos that they experience with their massive data. You can think of it as a library system that organizes your files more intelligently. We already use file formats like Parquet and Avro, but they are just like books alone. Apache Iceberg adds catalog card and library system into these files, and this makes managing the tables with SQL more easy. So what are the important features of Apache Iceberg? First, Apache Iceberg supports ACID transaction, which means safe and consistent updates. Second, Apache Iceberg supports schema evolution, which makes easily schema change. Then Apache Iceberg supports time travel, which means returning to past snapshots more easily. And lastly, Apache Iceberg supports partition evolution, which makes partition management more flexible. In short, Apache Iceberg saves our data lakes from becoming into data swamps and turns them into organized libraries. That's why giants like Netflix is using Apache Iceberg for the recent years. So, how Apache Iceberg achieved this? The answer is simple: by the metadata management. Apache Iceberg intelligently tracks where and how the data files are stored, not the data files itself. Apache Iceberg creates manifest files for each data files, and you can think of these manifest files as the library catalog cards. In these cards, Apache Iceberg stores which partition these data files are belongs into, which range of values it contains, and which columns it includes. And these manifest files are collected into a box called manifest list. So instead of scanning hundreds or thousands of data files, Apache Iceberg only uses these cards to find the data file. And at the top we have got metadata files. Metadata files are just like the general management plan of the library. Metadata files include partition strategy, snapshot history, and table schema are all stored here. And the result, when executing the query, Apache Iceberg don't scan entire data lake. It only opens the necessary files. This means you gain speed, flexibility, scalability, and organization. Let's try Apache Iceberg with two different demos. First one will be from a cloud environment by using Databricks Free Edition, and the second one will be from your on-prem environment. We will use Dremio, Nessie, and Minio. So let's get started. In my previous videos, I show how to sign up for Databricks Free Edition. So for this demo, we will use Databricks Free Edition. I already created a simple SQL query to create an Apache Iceberg table. The only important part here is this using Iceberg section. So by adding this part, this table will be created as Apache Iceberg table. So let's create it. Okay, in 8 seconds, my table has been created. Now let's check our table. From the catalog, we can find that under the workspace, under the default schema, I created my Iceberg table with the name test as Iceberg table. And in the overview part of this table, you are able to see that this is indeed an Iceberg table. So since this is an Apache Iceberg table, you will be able to use features such as time travel. From the history section, you can find all the history details of this table. And also from the lineage section, if you have some lineage information, you will find all the details from here. So that's all from the cloud demo. So for the second demo, we will use Dremio, Nessie, and Minio to create our Apache Iceberg environment in our own computer. We will follow this page to create step-by-step Apache Iceberg environment. So let's get started. When you go down below, you will see the required Docker YAML file in this page. The important point here is, as a prerequisite, you need Docker already installed on your computer. We will use the following Docker Compose YAML file. So just copy this Docker Compose YAML file into your favorite IDE environment. I will use Visual Studio Code. Okay, so from the Visual Studio Code, I will first start from the Dremio container. So let's start this container up, and in parallel I will start the Minio container, and finally I will also start the Nessie container. Once all these three containers are up and running, go to localhost 9000 to log in Minio. In the Minio login page, we will use the credentials given in the page and start the login button. From the create bucket, you can easily create a new bucket. Since I already created a bucket with the name warehouse, I will not create again. Then we will log in into the Dremio portal. Once you log into the Dremio portal, you need to configure the Lakehouse catalog. Configure the Lakehouse catalog, just click the Add Source button and select NESI. In the source settings, enter the related endpoint URL. And in the storage section, please select AWS and as the root path, write the S3 bucket name that you just created. I write my S3 bucket name as the warehouse. For the authentication method, select AWS access key and add the access key and access secret. And please add the connection properties that you can find from the guide page. Once you configure everything as mentioned in the document, click Save button to save your NESI configuration. Once your configuration is completed, we can run our SQL codes. Click the SQL Runner button in the port. I will use the sample SQL query code that you can find from the Dremio page. I just copy this code to our SQL section in the Dremio page. Before running your code, please don't forget to select the context. Select your context as the NESI environment. Then you can run your SQL query code. So our table is created. Now let's insert some data inside our table. So I will again use the sample code that you can find from the Dremio page. Okay, we added 10 rows to our sample table. Now let's return back to the menu console to see the details of this file. Now I am in the menu object storage page. Here you will see that a new folder has been created when I create that table. If I go to the inside of this folder, you will see two separate folders again. One is a unique number, which contains all your data files. The other one is the metadata folder. Inside this metadata folder, you will be able to find all the manifest files and metadata file that Apache Iceberg has been created. So in this demo, you can able to see all the metadata and manifest files that Apache Iceberg created by using the Dremio. Let's compare Apache Iceberg versus Data Lake. Let's start with the similarities. Both Apache Iceberg and Data Lake are table formats. Both of them support ACID transactions. Both of them provide schema evolution and time travel. In essence, both of them turn data lakes into organized tables. Let's get into the differences. Iceberg is an Apache project. It's very open, very widespread. It works with many different engines, such as Amazon Athena, BigQuery, Snowflake, Apache Spark, Trino, and Flink. Data Lake is, on the other hand, a Databricks product. It has been open sourced, but it is still strong in the Spark and Databricks ecosystem. Apache Iceberg manages metadata with the manifest files. However, Data Lake uses transaction logs. And partition evolution is actually Apache Iceberg's secret weapon. In Apache Iceberg, you can change your partition strategy while you are using your table. However, it is very limited in Data Lake. So who uses which? Apache Iceberg is being used by the tech giants such as Netflix and Apple. On the other hand, Data Lake is being used by the Databricks customers. So in summary, if you want to work with multi-engine, multi-cloud environments, Apache Iceberg could be your first choice. But if you are already using Databricks and Apache Spark, Data Lake will be your first choice. In summary, both Apache Iceberg and Data Lake solves the same problem with different approaches. Apache Iceberg is open and powerful at scale. Data Lake is fast, practical, and well optimized in the Databricks ecosystem. The competition between these two formats will be much more interesting in the future. So, which one do you think will win, Apache Iceberg or Data Lake? Write in the comments. I'm curious about your experiences. If you liked this video, please don't forget to subscribe and like. Thanks for watching.